The compression factor for a gas sample is 0.90. Its pressure is 20 atmospheres. If the gas were ideal at the same temperature and volume, the pressure would be A. higher than 20 atmospheres, B. lower than 20 atmospheres, C. the same, or D. different, but information is insufficient. The compression factor, often represented by the letter Z, is simply calculated as PV divided by nRT. Let's rearrange this equation to solve for the pressure of the gas. We find that the pressure is just equal to Z times nRT over V. But nRT over V is simply the pressure of the gas if it were behaving ideally at the same temperature and volume. Therefore, the pressure of the gas is equal to Z times the ideal pressure. We can rearrange this equation to show that Z is simply the ratio of the pressure of the gas to its ideal pressure. Since we are given that Z is 0.90, we can conclude that the pressure of the gas is lower than its ideal pressure. If Z is less than 1, then the numerator is smaller than the denominator. The actual pressure is smaller than the ideal pressure. Therefore, in this question, we have here the given pressure, 20 atmospheres, is smaller than the ideal pressure, or we say that the ideal pressure is higher than 20 atmospheres. The correct answer is, therefore, choice A. The ideal pressure is higher than the actual pressure. In fact, we can calculate what the ideal pressure is, since Z is equal to P divided by the ideal P. We can calculate the ideal pressure by dividing the pressure by the compression factor. 20 atmospheres divided by 0.90 gives us 22.2 atmospheres, which is larger than 20 atmospheres. At the molecular level, what does this mean? A compression factor less than 1 means that the deviation from ideal behavior is primarily due to intermolecular attractions. Pressure is due to collisions of gas molecules with the wall of the container. A pressure lower than ideal means that attractive forces are pulling back on molecules as they approach the wall. This means that the molecules will be slower when they collide with the wall, and the observed pressure of this gas is lower than the ideal pressure.